Hello, everyone. Good morning. Today we'll be talking about sockets with me and Jackie. Before we get started, I'd like to give a couple announcements. So first of all, milestone 1 should be graded, and you should be able to see that it has been marked off in your portal. If you submitted something late or you submitted through video, we are still working on some of those submissions, so you can sit tight for that. And if you do want credit or be eligible for the competition and have not submitted something for milestone 1, you should do that. We'll be closing submissions tonight at 11 to 9 p.m. Reminder, there are office hours tomorrow, 7 to 9 p.m. and 32082. You can come to learn anything about content, get help on your own projects, or just ask us any sort of other related questions. There won't be office hours tonight, but there will be a hackathon on Friday from 7 p.m. to 1 a.m., also in the same room, 32082. You can also drop by virtually on the help queue, just like for all the office hours. You don't have to stay for the entire time for the hackathon, but staff will be around to give a lot of help in case you're working on your projects. We'll have snacks, potentially boba or cookies or something, some good stuff. But yeah, so you should come out to the hackathon if you need anything. All right. So without further ado, let's get started. So at the end of workshop 8, we made something called Chatbook, and it looks approximately like this. This is before most of the messages were sent, but it has an all chat feature. We have the ability for users to send messages. You can type in new messages and submit, and you can see other people's messages, which is pretty cool. So we basically done Chatbook. Before we move on, I'll give you a quick story. This is an 85% true story. Do not worry too much about the details. So the night before workshop 8, the CEO of Chatbook comes over to WebLab, tells us, unfortunately, our customers are mad that you have to refresh to see new stories. They want some live interaction and chat. So please make something for them. And so, us being trusty WebLab staff, we tell them, I got you, bro. And so after workshop 8, we give them this thing, and they give us, their most natural response, which is, bruh, you still have to refresh the page to see new messages. So we kind of didn't actually do what we're supposed to do. And so today, we'll fix that. And we're going to use something called socket.io to create actual real-time chat. So this is what you came for. So how we want this to work is, say we have 3 clients here, Fluffy, Whiskers, and Joe. They're all logged in on the Chatbook website. We have our central server here. And so one of our clients, let's say Fluffy, decides to send a message in all chat. So what that'll do, which is what we made yesterday, they'll send a post request to the server, to the /API/message endpoint that we created with some content. In this case, Fluffy says meow. And then we want the server to then effectively send a post request to the other clients, telling everyone that, hey, Fluffy just said something, and the content of what Fluffy just said. Now that would be pretty cool, and that would basically solve our problem, but unfortunately, you can't actually do that. And that is because the server cannot initiate conversation. Notably, for HTTP requests, which is what we've been using for between the client and the server, the client has to send a request to the server, and then the server comes back with a response. So the server can't just give the client information for free. The client has to ask for it. And that's kind of a problem for us. So how do we fix this? Well, one way of doing it is what we call polling. And that is where the client repeatedly makes a GET request just over and over again, asking if there's any new information. So for example, Joe here might send a GET request to the server, ask for any new messages. Server says no. Maybe 1 second later, Joe says, any new messages? Server says no. Joe asks the server, any new messages? And maybe the server says yes. So this is one way of, being able to sort of get the information on the server effectively when you want to, but it's kind of inefficient. And that's because Joe is here, he's asking a bunch of questions over and over again. He's making a lot of API requests, a lot of HTTP requests. And it's just overall pretty inefficient, and it can kind of slow down your program. So why don't we just teach the server how to initiate a conversation? And so it actually turns out that we can, using a library called socket.io. Socket.io is a real-time library for JavaScript that is built on top of a special protocol called WebSocket. WebSocket is different from normal HTTP requests. It goes through a sort of entirely different protocol. It's a bit newer. I think most modern most modern browsers support WebSocket. Like pretty much anything that's like at most 20 years old is like good enough for WebSocket. So how Socket works is it's kind of, you can think of it as like a sort of upgraded connection. So Joe here, who's a client, is trying to talk to the server, and they started out using a basic HTTP request, but Joe might tell the server, hey, I'm going to need to talk to you a lot later, and I kind of want you to be able to tell me things later. So why don't we shake hands and sort of upgrade our connection? And so Joe tells the server, let's make a socket. The server says, okay. And it sort of upgrades the connection between Joe and the server. So now Joe and the server can both send messages to each other, and no one has to specifically ask for something and get a response. They can just send information. So maybe sometime later, the server can then tell Joe, Fluffy sent this message. So the server doesn't actually have to wait for Joe to initiate anymore. All right. One way to think about this that you might find useful is, these like string phone things. I don't know if you've seen these before, but you can like have one person talking to the cup and the other person hear it. Other person can also talk into the cup and you can hear it. Either person can just sort of say whatever and like listen. You can also have a server talking to multiple people at the same time through a sort of different connections. And we'll talk a little bit more about how these sort of different connections work. And then for the purposes of, well, all chat, at least for Chatbook, the server would essentially just broadcast one message to everyone, and they'll all be listening. So you can do that. So yeah, when we have these sockets set up, the way that we're going to use them is, Fluffy, like our client here, will post a message just using a normal API request. And then the server will then use its socket broadcast to essentially just tell everyone this message. And then now all the clients can sort of hear this message and know that it's been updated. So how does it look in the code? First of all, we have this thing called Socket Manager. So Socket Manager is a sort of wrapper for some machinery that we built for you. It like just lets us manage like where all the sockets are and their connections. We have this thing called get.io for Socket Manager, and that is a shorthand way of saying all of the sockets, like all of the sockets the server has opened. The .emit is what you'll be using most. .emit just means send information. So I'm emitting information to someone else. When you emit information, you need to have two parameters. The first being the name of the thing that you're emitting. So I can say, oh, I want to emit information about my message. So maybe I'll title my message, or title the thing I'm trying to emit like message. And then we also need to have the data that we're going to emit. And so that data can be pretty much any kind of format you want, like an object, you can have lists, strings, just actually like normal variables, etc. You can kind of choose. And on the other end, for the client needs to use something called socket.on. So socket.on is essentially the client saying that it's listening. So it's something for the client to listen to a specific type of event, because maybe there's all sorts of different events going on, and the client doesn't really care about all of them. They just want to listen to some certain like few specific ones. So the client can describe these by saying socket.on, the name of the event, and then in the second parameter, you pass in any callback function, and the client will essentially do that function when it hears this event has been broadcasted. So let's give a sort of simplified example. We might have an example of having like a professor who is posting a new piece set. So they would emit a new piece set, and the sort of data they would emit is just the contents of that piece set. It might be like an object. And then you have a bunch of students in a room, and then students might set up socket.on, and then when they see a new piece that has been emitted, they'll start working on it. So that's kind of how you might want to think about how socket kind of works. Now, if you look at like a little bit more in depth into like code, this is still not quite accurate, but I guess might be a little bit more helpful. You can see the professor uses something like emit, the name of the thing that are emitting, which in this case is new pset. They have some object, which might have some information like the due date and the questions, etc. And then the students use socket.on on that same event, which is new pset. And then they have a callback function, which is, while pset is not due tomorrow, procrastinate, otherwise solve the questions. So you can kind of put whatever callback you want, on the client side. In our case, we have socket manager to get IO. Remember, that's just a sort of a way to say all the sockets in the server. And then we are going to emit to all the sockets a message. And that message will have like some object attached to it. That's like the actual contents of the message. Maybe it also has the person who sent the message. And then on the client side, each of the clients will run socket.on at the start, like when they load up. And they'll be listening for a message and run a specific callback function when they hear that message. And that callback function, that's what the CB stands for. All right. So let's add this chat book. So before we actually get started with the code, I'm just going to recap some of the stuff from workshop 8 real quick in terms of the sort of structure. We added this entire section on the right for chat book. We primarily focused on the chat, the single message, and the new message yesterday. And today we'll be getting into a couple more components. The front end looks kind of like this. Oh, that K is kind of sad. Oh, well. We have the overall chat book page. This is divided into two components. The left-hand side, we have the chat list, which just shows who is online. It also allows us to click on their name and chat with them. The right-hand side has the actual chat itself. Has people sending chat. You can see their messages. You can also send your own messages. So on the left, we can break this down into a bunch of single users, and you can click on those users and talk to them. And then on the right-hand side, we break this down into single message and new message. So each single message is just a message that we can see, and the new message is just the ability to kind of submit a new message. Here's a quick recap over some props and state. I won't really go too in-depth into this, but this was also in workshop 8. And then for the backend, we made two main endpoints yesterday, router.get/chat. This is just getting all the messages in the server, and then router.post/message, which is sending a new message to everyone. So we're going to add this specific new endpoint here a bit later. We'll also add a couple more relating to the active users. And so sort of quick recap of the design, you can refer back to this if you need to, but I won't really go into in depth into this part. So let's get started. Why don't you open up Catbook React, make sure you run git fetch and git reset -- hard. One thing you should remember is if you made any changes and have unsaved files, you should press save on those files before running git reset -- hard, or else it will not recognize that that change has been made and not clear it for you. And then once you've done that, run git checkout w9 - starter, and that should bring you up to the branch that we'll be working on for today. You should also run npm install once you've gone onto the branch. This is not generally necessary every time you want to run something new, but we just ask that you do it here because the socket IO library, I'm actually not sure if it's in some of the previous versions of Catbook. So I just want to make sure that you are installed with the latest dependencies. And then once your npm install has completed, it should say something like a bunch of packages either added or removed or audited. And then you should try starting the hotloader and the server. Remember, you can start the hotloader with npm run hotloader in the terminal. You should also open up a second terminal and run npm start. So this will be the server. The hotloader will be the client. And you might find it useful to have a third terminal for git commands. So you can run git commands without having to stop either the client hotloader or the server. So I guess I'll leave that up for a minute. Wait, there's like a bajillion things afterward. So this is like halfway. Wait, can you pull up your code? Yeah. All right, so I'm going to demonstrate some of that here. I guess I just need so I guess I can do it for a second. Git reset dash I should run git fetch first. Git fetch, git reset dash dash hard. Git checkout W9 starter. So I have 3 terminals opened up here at the bottom. Hopefully you can see. My head might be blocking it. I apologize for that. So I'll use the second terminal, run npm run hotloader. And I'll use a third terminal for npm start. Yeah, so if we take a look and we open up a browser with localhost 5050, we should see pretty much what we made at the end of workshop 8. I'm going to log in and show the chat section. It should look something along the lines of this. Oops. Yeah, so we have our all chat, we have our messages, and it can also submit new messages. If you try to submit a message, it will not immediately update for you or anyone else, which is kind of annoying. So we'll fix that. I guess the first thing that we want to do, let's go to the slides. Yeah. So one thing to note about this workshop is that there might be a bit more involved coding and stuff. And we were going to be working in a number of different files. Some of these things might get a little like messy. And so what we have on the side, second presentation that will contain some extra useful information for when you are actually trying to code this up. You can access this at weblab.is/w9-context. If you are joining us virtually, you should open this up on a separate window. It'll just be pretty useful in general throughout this workshop. The main slides can also be accessed at weblab.is/w9-slides. So we'll sort of split the slides into 2 presentations. Yeah. So W9-context for the context slides on the side, and W9-slides for the main slides. All right. So the first step that we're going to do is fix all chat so that it actually loads the messages immediately. And remember at the top, we have a message that says git reset dash hard, git checkout W9 starter. This is just going to be there pretty much on every slide throughout the workshop. So if you ever get lost or have for any reason need to catch up, just run those commands and you should be good. So in order to see the messages instantly, we're going to have to add a couple socket things. So we have set up the socket like infrastructure already for you. And we need you to add a couple things. Yeah, so just like we mentioned earlier, we need to add two main components, one being on the server side. That server side component will be socket manager.getIO.emit. Remember, socket manager.getIO is a shorthand way of just referencing all the sockets on the server, and the .emit will be the thing actually sending the message. On the client side, we'll need socket.on to listen to that exact same message. Remember, the name of the thing, the event being emitted, in this case, this message, has to be the same for both the server and the client so that they know what they're talking about. So why don't you take a minute or take a couple minutes and try to implement these on your own. The files that you will need to change are actually listed at the bottom here. And that is going to be in line 98 of API.js and line 54 of chatbook.js. They should also, I think they might be marked with to-dos as well. So why don't you all take a couple minutes and try to see if you can do it on your own. It shouldn't take more than probably 2 or 3 lines of code at most. So yeah, why don't you try it out? If you have any questions, remember, you can ask on the questions doc at weblab.is/questions. You can also put yourself on the help queue at weblab.is/queue. Yeah. Sorry about that, guys. I think the line is different. It says line 60. This is line 54. Oh, that's crazy. Also, it should be probably line 60, not line 54. But I think if you look in that general area, I think there should be a to-do in comments. Is that true? Do you want me to look? Sure. Actually, change. Wait, where's it to be? This is starter. This is starter. Oh, am I in the wrong file? No, you're. Wait, that wasn't there before. Oh, really? The dot then. Oh. You add the same line. Same line. Okay, it's just like instead of it's just like it doesn't look quite like this. It's more just not good message. It's okay. It's like this. Yeah. Like it's like the same, it's just like that. We apologize, the line numbers are slightly wonky, but you can look for these sort of same part. Should be messy. Yeah. Why is it all the way down there? That's crazy. Wait, why is this here? No, that's right. Okay, that's not that one. Oh, 98. Oh, wait, no, that's correct. Oh, yeah. Oh, it's chatbook. Okay, I know chatbook line 60, API line 98. That's. Oh, yeah. Oh, whoops. This is the wrong slide.
Yeah, I read this and I read this.
Yeah.
Okay, all right, I'm good. Just let me know whenever.
Could we get a quick show of hands to see if anyone has successfully been able to get socket messages to work? Okay, I'll give you all like another minute, and then we'll go ahead and show how you can do that. One thing to remember, though, when you do implement sockets here, is that since you're still running your server on your local computer, like using npm start, and you're accessing it on localhost 5050, if your friend on a different computer sends a message in all chat, you will not be able to see it yet. You can't like see it immediately. You'll still need to refresh even if you have sockets working correctly. The way to test this is to actually open up either two different browsers or open up one browser in incognito mode. And so you can essentially talk to yourself on the same computer, but with two different accounts. Yeah, I've definitely had moments where I'm like, I don't know why my sockets don't work, and I realize I'm on my own computer. So there is no one else to talk to anyway. I'll give like another minute, maybe another minute and a half. Only talking to police. All right, why don't we take a look at the code and see what we can do. So first of all, if we go into step 0.1 is in API.js line 98. You should see a to-do along the lines of this. It says emit to all clients that a message was received. And the way that we do that is using socket manager.getIO. And that just references all the sockets or all the clients with sockets on. And then we emit to them our message. So right here, we've already written message.save from yesterday, and that just saves the message to our database. But we also just want to update everyone else and let them know what messages were just sent. So we can emit this message to everyone who is listening. All right. So that is the change we'll be making to API.js line 98, or line 99, I guess. If we go to chatbook.js, which is the client, we can turn on our socket. So essentially, we'll be listening for this specific message. And on line 60, you should see a to-do, that's step 0.2. So we'll just write socket.on message. And then we'll pass in a function, add message. I believe that function should already be implemented for you somewhere in Chatbook. Oh. Is it not in there?
Oh, that's not.
Okay, but yeah, we want to add a message to the list that we see when we hear the socket message. And we also probably want to define add messages.
Yeah.
I guess one important thing, or I guess this was not intended for y'all to implement, which is kind of our bad, but we will show you what add messages, what it should do, I guess. So notably, add messages is supposed to append that message or append whatever message you receive onto the end of the messages that you have currently. And we'll walk through this in a minute because this is a little bit involved. So the main thing that we're focusing on here is that the thing that we want to set, which is, or the variable that we actually have is active chat. So remember active chat contains a recipient, which is the person we're speaking to. In this case, it's just all chat. And it has all the messages. So if you scroll up slightly, you keep on. Yeah, you'll see this use state here that has a recipient of all chat and messages as just a list of all the messages that have been sent. So we want to use the set active chat setter to change the state. And how we'll do that is if we look at the add messages function that we just wrote, this uses set active chat. We want to make sure that we still keep all of the previous messages. So that's what the previous active chat is referencing. And then we want to set the recipient to be the same because we are just getting a new message. We aren't changing who we're talking to. And then we want the messages to be the same, but you add like whatever new message you just heard. So I think this works actually. You can try it out. Try demo. Oh, actually, Jackie is writing a very interesting line here that I actually didn't mention earlier during the lecture. So this is actually, I think this is very interesting because you strictly speaking don't need this section, this return to socket.off. Just having socket.on will work actually. But this return statement is when you learned in React Part 2, this is what we do for a dismount actually. So remember, like returning something in this use effect written like this, we'll do it when the component dismounts, like when you leave the page or unload the page for some reason. And in this case, we just do socket.off to like sort of close our connection. Strictly speaking, this is not necessary, but it is very good practice because it will reduce lag on the server side. So the server won't have a bunch of open sockets with people who aren't actually there. But yeah, why don't we try it out and see? Wait. Yeah, so I guess in this demo, we just saw the browser on the left and the browser on the right are logged in on two different accounts. So the one on the left is in incognito. Sending a message from one browser immediately gives you another, or immediately shows that on the right browser. So that is how sockets work. All right. Yeah, so if you check out, or if you do git reset dash hard and run git checkout w9 step 0, this should bring you up to what we just made. And this will show you kind of what or how the sockets work. Don't worry too much about the set active chat, like the add messages function. That is essentially just a wrapper to run the set active chat setter and actually display the new message at the bottom of the screen. Yeah. So the next thing we want to look at when we talk about sockets is how do we send DMs? So right now we have all chat, but sometimes, when we're sending to all chat, everyone knows what we're talking about, and we might not want everyone to know what we're talking about. So we want to privatize some information. So for example, if we take one client, let's say Fluffy posts a message to the server. The server sends this message to someone else through a socket. Well, it turns out that IO or socket manager.getIO.emit references all the sockets, and this is public. So everyone that is connected to the server can hear the same message. And so there are people who you may not want to, or that you may not want to have hear your message, and also get access to this information. So we don't want that to happen. So in order to fix that, we have to look a little bit deeper into how Socket Manager works. So behind the scenes, we have our client Fluffy. They're sending an API request to the server. We use this thing called socket manager.getIO.emit to send a message to everyone. Turns out how that actually works behind the scenes is the server has a list of a bunch of sockets. So the server just has like all of its connections stored somewhere. And it broadcasts that information to everyone, to like all of the sockets. It just goes down the list and gives everyone the same message. And this sort of collection of sockets is the sort of get IO thing. The IO object is just sort of an overall controller for all of these sockets. And then once you use that IO object, you can reference all the sockets in it and then send a message through each of those sockets with like the sort of same message and the same content. So this is how the broadcast actually works behind the scenes. Now, if you want to send messages specifically to one person, well, we do have sockets to only that one person, right? So we can just send a message to that specific socket. But the problem is the server doesn't actually know whose socket belongs to who. It just has a big list of all of them. One way you might think about this is maybe the server is someone like MIT administration. You know, you like walk in on orientation day. They give you an ID card. Now the person at the table who's supposed to give you the ID card will look you up, give you the ID card, and then you go on your way, and they don't remember what your ID number is anymore, but it's written on your card. So the same way here, you, the client, actually remembers your socket number or your socket ID. So when you are first assigned a socket, you know the identity of that socket, and you can then tell the server, hey, it's me, here's my socket ID, and you can write me down in your database so that you can communicate with me in the future. So in order to do that, or after you do that, the server can then check what we call the request.user and just look at your ID and find out what socket you're on. And so we do this thing with socket manager.addUser, which is what it does is it adds you with your socket ID or like your specific socket, so the server can remember whose socket is whose. And so this is all done on the initial connection. So you log into the page, you click the login button, the server tells you that you're logged in, it gives you a socket. You then tell the server, here's my socket ID, server writes it down, and then we're good to go. So now the server knows whose socket belongs to who. And if you want to emit a message to a specific client, for example, Fluffy could send a message to the server can then just choose that specific socket for the client you want to emit to, and then emit to that person. We have a map stored on the server side, which we'll get to in a minute. That is called socket manager.getSocket from user ID. And it's like a very long name, but it does exactly what the name suggests. It gives you the socket for each, like if you pass in a user ID, it'll give you that user's socket. And so this function is actually written for you. You can take a look at it in the code and we'll look at it in a minute. But this will allow us to take any user ID that is logged in on our website and find that user socket, send messages to that person, or send whatever information we want to that person. All right. So yeah, once you have that, you can emit to that specific socket. The notation is very, very similar as what we did for all chat. We still start with socket manager because that's the thing that's controlling everything. But instead of using .getIO, which gives you all the sockets, we use getSocket from user ID and then just pass in that ID. So this will give us that one specific socket. And then we use the same .emit notation to send the message and the content. And we will demonstrate that in a minute. But for now, if you need any more information or would like reference later on, you should go to weblab.is/chatbookguide or chatbook docs for information about how chatbook is structured throughout this workshop, and weblab.is/socket guide, which will have a lot more information about sockets and a bit more just general documentation. If you want to do any projects related to real-time updates, you might find the second resource here very useful. And you feel free to reference that as you're working on your own things as well. So I'll give you a minute to open these up. I think they're pretty useful to just have open or to look at if you want a little bit more information or context as to how chatbook or how sockets work. All right. So with that being said, we now have everything we need for DMs. And so let's talk about how we're going to structure the rest of this workshop. Remember, if you want to look at the finished product, you can look at weblab.is/example. There's also a game tab on there. We will not be making that today. That will be tomorrow's workshop 10. But we will be working on the chat page. So here's our component tree. We made this stuff on the right, but now we're going to start shifting over to the stuff on the left, which has the chat list and the single user, so we can speak with individual people. if we look at the components, we can map out their states and props. There's a lot of things on this page, and it might look a little complicated, but I'll walk through this a little bit. At the app level, we have a user ID. That's just who you are when you log in. We'll pass that down pretty much all the way. On the chat book level, we have a state as active chat. That's just telling us, who we're talking to right now. If we're talking to all chat, it'll just be like a constant string or something. For active users, this will just show, the big panel on the left. It shows all the users who are currently active, and this will be stored as an array of user objects, and we'll code that up later. From the chat book page, we can pass down a prop to the chat list, which is the actual list of people on the left. And that is going to pass in a couple of things. Set active user is a function which changes the current active user to whatever person we click on. User ID is going to get passed down. That's just who you are. The users is an array of user objects. There's just a list of all the people that are on. And then active is the user object of the person that you're currently talking to. And then in the chat list level, we don't need to really store any states, but we're going to pass in a little bit more information down. And that is, we're still going to pass down the set active user function to the single user, because we want the ability to click on a single user to set the active user for the entire chat book page. We'll have the user object be the user itself, and then we want a Boolean to check whether this user is the active user or not. So this might look a little complicated and a little daunting, but don't worry, we will get into that. But yeah. On the back end, we have our socket connection. We have set up the socket connection already, but this is going to require a little bit more work. And that is because we want to make sure that we can reference individual people. So we have an HTTP request, which will be a post request from the client to the server, telling the server to initialize our socket. This is also going to tell the server, what our socket ID is. The server can remember that for future use. And this will happen on login. So when you click the login button, you get logged in, immediately send an API request to the server telling it that, this is our socket number. You can call us whenever at this number. This server needs to have the ability to emit a list of all of the active users to everyone. So this is just the sort of bar on the left showing who's online. So I just want to have a way to sort of update who's online as people log in and log off. So if you log in, new person shows up on the left, and if you log off, you will no longer be displayed on the side. Notably, you don't want to have to refresh to see who's logged in and who's not. So this will also be done through sockets using the emit to send that information. But just in case your socket breaks, it's good to have a backup with just a regular HTTP request. Also, for example, if you are logging into the page for the first time, good to have an HTTP request just to get that information there. You can update it later if you have more stuff. So we want just a regular old GET request to get that same information. All right, so now let's code it up. And if you want to catch up to where we are, git reset -- hard, git checkout of the W9 - step 0, and we will get rolling.
Okay, so as Nick laid out the design and all the details, it might seem like a lot, but we're going to walk through each part of that design step by step. The first of which is the init socket endpoint that Nick most recently described. I'm going to head over to VS Code now and follow the steps that you saw on the previous slide. Reset hard, and then git checkout W9 step 0. Okay, so now we should all be on the same page. And as Nick said, init socket is the endpoint that we'll be using for the server to keep track of which user is associated with which socket. And so since it's an endpoint, we go to api.js and head over to around line 77, where the placeholder code is already there. Okay, so right now it's not doing anything, but one thing that we do want to check for before the callback does runs any additional code is check whether the user is logged in or not. We determined that we don't want the user that's not logged in to access the chat. And so we can just check that by seeing if rec.user is some blank or empty value. And then from there, we can use the socket manager and specifically the add user method to start keeping track of this user who's just hit the init socket endpoint. If we look at the syntax, we can add, or we pass in rec.user and then a socket. And we can use socket manager again here. Specifically the get socket from socket ID method. And then for that, we get the socket ID from the request, which we'll promise ourselves that it will be there later on in the rec.body object. Okay, so at this point, the server is ready to receive requests to the route /init socket, but now we have to apply the change on the client side. So let's head over to app.js. Okay, and in line 36, we have a to-do. This is the callback that's run when the user attempts to log in, and if successful, it sets the user ID, which is something from previous workshop. But we also want it to connect to the server through sockets. And so using the endpoint we just created, we make a post request to /API/init socket. And as I mentioned earlier, we promised ourselves that we'll be passing socket ID as a field in the request. And so just to provide that information, we can make this an object like this with the field socket ID and the value socket.id. Okay, so right now, if you head over to the Chatbook app, nothing's going to look different. For a few steps, we're not going to change the way that information is stored or rendered, but we started by changing the server so that it can handle socket initialization. From there, we can start thinking about how to change things on the React side. So if I go over to Chatbook and log in. Right now, it looks like this, right? This is where the chat would be with all the messages and the text field on the bottom. The space on the left here is actually where we're going to have the chat list, and the single user components will be some header here, and then we can start clicking on names and changing which person that we're chatting with. And so to jump into that, I will open up single user.js and start putting up the first component that we're making. So I don't think you guys watching me live code HTML will be the most interesting thing or most efficient use of time. So I'm just going to copy this over here, paste it in, format that, and just walk through what this is doing. So single user is a pretty simple component. If you imagine there's just a div, and in these 3 lines, we're just adding some classes so that it's styled nicely, so that like when you're opening the chat with, say, person A, it will have a highlight behind it so that you know who you're chatting with. And then that's where the props.active comes in. So if we know that the user that you're currently chatting with is active, then we'll add an additional class to make it look different. But it's not essential to the functionality that we're working on at the moment. So moving on, after that, there's an on-click handler. All this is doing is changing the active user when you click on this component, when you click on a single user component. So that when you click on person 2, for example, you can see that person 2 is now the person you're actively chatting with. And then it displays the user's name. So then now that single user is completed, we can start working on chat list, which will be using that. Same idea here. I'm just going to copy and paste the HTML code in here, and then walk us through that. Format that. Oh shoot. Okay, there we go. Chat list it just consists of a header followed by a number of elements based on the user's prop. So basically what's happening is each user that's passing from the prop gets mapped into a single user component. And if we look back at the props that are required, you can also see this in the chat book documentation as well. But there's set active user, which is a function that we haven't yet defined. We'll get to it later, but it essentially does what I described earlier, changing the state that stores which user you're chatting with. And then the user itself and whether or not that user is active. And so we can get that information from each user element in the users that comes down from props. The active user comes from a higher up component. I'll get into that in the next few steps. But for now, let's just assume that it's going to be passed down as a prop to chat list as well. And then the key equals index I is something that's a little complicated. There's a good amount going under the hood that you don't have to worry about. It's actually not best practice to use the index itself as the key, but just for the sake of suppressing the warnings that we would get otherwise, we're just going to put this here for now and trust that in more normal circumstances, we would do a little differently. Do as we say, not as we do. Yeah, okay, so then with that, chat list is implemented, and it uses a single user. Now, something else that you may have noticed or that you may have thought about is where active users would be stored. Nick mentioned this earlier. We'll need an extra state variable. So essentially, if we open this thing back up again, we'll need something to store the list of users that we want to show up in the first place. And this list is not yet a state variable that's created. So we can go to chatbook.js and create that in step 2.3, step 2.3. Sorry. I forgot to, okay, so after we finished step 1, I forgot to check out step 1 so that it refreshes the code that we have. We're on the same page and that it updates our code with the subsequent to-dos. Let me fix that real quick. Apologies. Step 1. Okay, so step 1 is complete. Let me just paste the code back in here. For single user, and then chat list. Chat list is here. Okay. All right. Step 2.3. As I was talking about earlier, we want to create state variable active users that will store which users are active or online, so that you can later on click on single users and message them. We can start with an empty array for now, just assume that there's no active users. What we're going to implement later is code that will actually fetch information from the server and update live so that this list will not remain empty throughout, the lifetime of, or whenever you have the page open. Okay, and then one more thing I mentioned earlier, I kind of just brushed it off, was the function set active user. So we didn't put active the function in single user or chat list because depending on which user you're actively messaging, it will not only change what's displayed in the chat list, like which one seems active, but also the messages that are shown on the right side. Because if you're messaging person one, you don't need to see all the messages from all chat, for example. And so just to move the state to a component where all of that is connected, or sorry, move the function to a place where all that is connected. That's why it's going in here, and then there's a to-do down here to put that in. So we can create the function set active user, and all we're doing for now is going to be logging which user we just said it's active. We're going to add more functionality to this later on. It's just, it'll make more sense when the other pieces are in place. So for now, it's just going to look like this, some placeholder function that we can pass down into chat list and single user. Okay. But now, even though we've implemented the single user component and the chat list component, nothing is displayed on the web app yet. So this is where you come in. This is the first part that you guys get to take a shot at. Let me head back over here. Oh, let me hide this. So step 2 is done. Be sure to reset if you have any changes in your files and check out W9-step 2. And then here, all I'm asking is that you take a shot at implementing or adding the chat list component to the chatbook app. This should be pretty much like review. As a hint, this is the syntax that we would use to add a component into another component. And I'll give you a few minutes to do that.
Also, as a heads up, if there are any discrepancies in the line numbers between this slides and those slides, please reference the context slides because those have definitely the most accurate line numbers. Also, if you have any questions or would like to ask something, please post that on weblab.is/questions. And if you need more, I guess, involves help from staff, just join the help queue at weblab.is/queue.
Server client get. How's it looking for everyone? Still need time or no? Who's still working? Okay, I'll give you an extra minute or two.
Smiley faces. I have compulsion to put smiley faces after every message. I'm not the only person that does this.
I think I can stop. I can pause that after step 5 because if we just right here.
Sure. I also copied over the lunch slide onto this computer, so I can just display it if you want. But is it I have the lunch slide on this computer?
Oh,
So I just put these on the side.
yeah. All right, how's it looking for everyone? All right. If anyone's still working, I hope you still at least got a chance to give it a shot. For the sake of time, I'll be doing it on my screen and moving forward. So be sure to reset and check out next checkpoint, which was step 2. And then chat book. All right. So this is the chat book component, and in here we just want to include the chat list component on the side. So chat list, this, and then the 4 props would be set active user. We defined just earlier, so we can pass that right in. The user ID comes straight from the top and is passed through everything. So we can grab that from the props. And then the active users, we defined the state variable just above as well. And then which user is currently the active recipient. We can just use active chat recipient. Active chat is active chat was defined up here, one of the existing state variables. And yeah, so that concludes step 3. And let's go ahead and see what that looks like now in our chatbook app. Now, if we go to chat, we can see that chat list is existent. Now, right now, there's no active users that seem to be displayed because we've initialized the variable, the state variable, to just an empty array, which is unfortunate because then you can't message people, which is the goal. Well, this is also another part where you come in. The next step is hitting the /API/active users endpoint. So we're going to implement this on the server side so that the React app can ask the server for which users are active. If you, I didn't hide this thing again. If you reset and then check out the branch W9-step 3, you'll see a to-do in the appropriate place. And I'll give you a few minutes to try this as well. If you need a reminder on what kind of information what kind of data that this endpoint is supposed to return back, you can check it out in weblab.is/chatbook docs. There's a couple of hints on the screen if you need. Okay, hopefully that was enough time for people to try that out for themselves. I'll be doing it on my screen as well. Now, so I go to api.js and I'm just gonna add this. Oh, I didn't check out yet. Hit reset hard, get checkout. Step 3. Okay. This should be pretty straightforward. There's just one line that's needed. We're sending back an object with the field active users. And the information that we send back is a list of user objects, and we can get that using the method from Socket Manager called get all connected users. And then now the server is ready to handle any requests coming to this endpoint. Now that this is set up, step 4 is completed, and so I should reset and check out W9-step 4 so that we're all on the same page. And now I want to actually make use of this endpoint on the client side. So I'm going to head over to chatbook.js. And this data is something that I would only need to fetch each time that the page loads. At least I don't need it to be fetched every time that something on the screen changes state, right? And so I'll be using the use effect hook with an empty dependencies array. And what this does is basically just whenever this page loads, this page mounts, I'll be making the get request to the endpoint we just implemented once. And then once we receive the data from that, we will be setting active users to the information that we receive. So we want to include all chat, regardless of who's online, because it's just like a global chat that anyone can message, followed by the active users that came back from the response of the get request. Now, there's something that could happen if you were not logged in, but just to make sure that you only receive information and this list of users only displays when you're logged in so that you actually know you have access to the chat. I'll just be adding in one condition to verify that. And there we have all that it would take to load the active users when you first load the page. And I'm going to head over to the browser to demonstrate this. Okay, so now I can see that in the chat list, there's all chat as we hard coded in here, followed by active users. And currently it's just me. But if I log in as Puka on the left, and then I go to chat, then I can see myself and Puka. If we refresh the page though, we'll see that it disappears. But if you switch pages and then you come back, it's there. And this is because the get active users request that happens whenever this page is loaded completes before the logging in process is done. And so that get active users request that's sent to the server doesn't come with a user ID, and the server doesn't know that we're going to be logged in. But one way we can resolve this is just have the chat list update with each new active user. So have live updating. And for this, we're going to use sockets. And this is something that you'll get to try out on your own as well. So that was just step 5 that was completed. Be sure to git reset -- hard and check out the branch W9 step 5. So this next step, which you're going to try, is using the socket.on method that Nick had mentioned earlier to listen to the active users event. If you look in the documentation, the active users event is emitted every time the list of users are connected to the server through sockets changes. And so by listening to this event, we can then change our state in the React app whenever this happens. So I'll give you a few minutes to try that.
CS is pretty interesting. Person is kind of slow.
How many people are still working? Oh, okay. All right, then in that case, I'll catch up with you guys and do it on my screen. If we set hard. And we just finished step 5. So check out step 5. Okay. So we go to chatbook.js. So just like the listener that we created above right here for each message, we're going to do something like that for active users. So just to set up the same way first, we use the use effect hook with an empty dependency array so that this only creates the listener once. And then create the listener for the active users event. And then we'll write the callback in bits, but I'll just put callback here for now. And then a return statement to clean that up afterwards so that we don't have a bunch of lingering listeners. Okay. And then the callback is also pretty straightforward. Once we receive the data that comes through the event, all we do is set the active users to the same thing that we had earlier, all chat plus the list of active users. We're just doing it at a different point in time. So I can actually just copy this over, because we're expecting that active users will come with the data with each event, with each time that the active users event is emitted. All right, and then if I head over to chatbook, log in. All right, so right now on the right, I'm logged in, and we can see all chats and myself. And then when Puka Puka logs in, we will then be able to see Puka Puka update live in the chat list. And Puka Puka can then see the same thing. And if I disconnect, actually, like log out here, that updates as well. So now we have a live updating chat list that we implemented using sockets. So before we move on to the next step, we are close to lunchtime, and actually the food is ready to be served. Is that correct? Yes. Okay. It'll work the same way as yesterday. I think there's, oh, actually, there's more people here than I thought. But we'll open up to seconds at some point later on if there is enough food. Staff will announce it in the hall right outside this room, and then inside this room. The lunch today is from Boloco. Burritos and bowls again, similar to last time we got it. This time there's salsa on some of them, trying something different. But anyways, I think there's few enough people this time that I'll just release everyone. Should be okay. But just stick to one item for now, and remember not to eat in this room. Try to come back by 1, and enjoy lunch.